Okay, so in this video, we will talk a little bit about types of reactions. So for Chemistry 101, we needed to learn important type of reactions that we need to not only memorize them, but we need to understand and identify them in problems. So here we have the first type of reaction that we call combination or synthesis. Combination or synthesis is when you have an element A plus an element B making a compound AB. Basically, you just added A and B together. I have an example here where you have potassium solid plus chlorine making, oh, no, the two there. Which one here? Which one here? KCl, potassium chloride. Okay, so basically we have our element A, our element B combining, making AB. Another type of reaction is the decomposition. So this is what we call synthesis or combination. Decomposition is basically the opposite that we have for synthesis. Now we have AB, compound AB, and it decomposes, it breaks in A plus B. A classic example for this reaction, it's water, liquid, decomposing in hydrogen gas and oxygen gas. Okay, so basically we have AB combined together and it decomposes in A plus B. So both reactions, first the reactants in the synthesis, we have an element and an element making a compound. And here we have a compound breaking into elements, particular elements. Another one that is also important is called single replacement. What is a single replacement? So an element reacting with a compound. So we have an element A plus a compound BC. And we have a reaction going on there. And basically A replaces B. Okay? So this is a single replacement because we have an element and a compound, making a new compound and a new element. One classic example here, we have iron, copper sulfide, making iron sulfide and copper solid. Okay, so here we have our element A, our compound, which is B and C, and now we have A and C together and B by itself. Okay, and what is important to know about this reaction is that single replacement is always a redox reaction. We talked about redox reactions in a unit before, so identify that a single replacement is a redox reaction is an important key for this particular type of reactions. Now we're going to talk about, so this is the single replacement. Let's talk about the double replacement. The double replacement, basically, I have AB plus CD, and now everybody is going to change. So A combined with D and B combined with C. What I like to, how I memorize this is I combine the insides and then the outsides. So BC will be my product as well as AD. One example for this is an acid-base chemistry. Acid-base chemistry is a double replacement. So I have here potassium hydroxide plus sulfuric acid. So if I was going to write it, this is my A, B, C, and D. Now I know that insides and then outsides. So HOH, that I can call this is H2O, it's a water, okay? Plus K2SO4. So for double replacement, in double replacement reactions, double replacement reactions are not redox reactions. A special type of double replacement is called acid-base chemistry. We need to remember that B always combines with C. If I look at in a particular molecule here, and in my particular compound, here, I know that A is my cation, while B is my anion, C is my cation, and D is my anion, meaning that the anion from the one compound combined with the cation from the other compound, and the other cation combined with another anion. This is why I say B combined with C and A combined with D. So now that we understand synthesis, decomposition, single replacement and double replacement, I want to do some examples on the board where we need to identify what type of reaction I'm dealing with, and this is how your problems in Chemistry 101 will be. So they gave me a HCl plus an AOH. So, and they say, tell me what is the final product, what type of reactions we have there. So I look at for this particular example, first of all, I know this is an acid because it starts with an H. I know this is a base, we have a hydroxide on this side, but I can also break this apart and have A, B, C, D. So if I have two compounds, I know that in the final product, B will combine with C and D will combine with A. So we'll have HOH, which is H2O, plus NaCl. In other words, and this is A, D. Okay, B combined with C, Na combined with D. So when the problem gave you the reactants and asked for the final product, you need to look at here and say, well, do I have two compounds? Do I have two elements, or one compound and one element? What I have here in my reactant side. Once you identify what you have in your reactant side, makes your question way easy. So another example here that I have is sulfur in an oxygen gas. So I look to this particular problem and I say, well, I have one element and another element. So I have A and I have B. So I look to my notes and I say, well, if I have two elements, A and B, they combine in the final product, making the AB compound. So therefore, this is SO as my final product. SO2. Okay, the next one example that I have here, I'm going to use another color. This is Mg plus HCl. And they say, what is your final product? So if I look at here to my reactant side, I know that I have an element, and I know that I have a compound. So I need to look at my notes again and I say, well, element plus a compound. So I have A plus BC. So this is a single replacement. The single replacement, the A combined with the C and the B stay by itself. So I have as my final product A combining with C and B staying by itself. Okay? Another problem I have here, H2CO3, carbonic acid. And then my question says, well, what is the final product? What is the product side? I look at here and I say, well, this is a compound, A, B, combined together. Therefore, if it is AB, I can break it apart in H2O plus CO2. This would be the decomposition. So, just a review from what we learned in this video. Every time you have a question that gives you the reactant side and don't give you the product, the first step is identify what type of reaction you're dealing with. In the case of HCl and NaOH, I know that I have a double replacement. Why? Because HCl is a compound and NaOH is a compound. So I know that I have AB and I have CD. Therefore, when I predict my product side, I know that B combined with C while A combined with D. So I can write in my product side. Sometimes they're going to give you the same type of question, but now I do not have two compounds. I have an element and another element. So I have A and B, and I know that when A and B, two elements, they can combine together and make a synthesis, a combination reaction. On here, I have an element plus a compound. So I look at my notes and I say, well, an element plus a compound, this needs to be a single replacement. And as a good review, I know that single replacement is always a redox reaction. So now I know that A combined with C and B stay by itself. And on here, I have AB as a compound, and I can break it apart in two other compounds, or it can be two other elements, like in the case that we had before, H2O, that makes H2 plus O2. Could be, or it could be two other compounds. And this is a type of reaction you need to know for Chemistry 101.